Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1. This is the last packet. Boom shakalaka. Packet number 6. And let me tell you, it's a doozy. But it's okay because we're going to break it up into 3 days. We're just going to take it a little bit at a time, process everything, work through some old stuff. So this is polynomials and factoring along with quadratics, which are two of the biggest units that we deal with. So lots of really good information in here. So we're going to take our time. We're going to work through it, recall a lot of things that we've already worked through. Everything in here you've seen once already. So do not be intimidated. And if you don't understand something, this is a great opportunity to work back through it. So without further ado, we're going to start off in our first section here. I'm going to try to take my time and really explain things as we go, but and especially in this first section, I love the way this is broken up because it's such a great way to see all the different types of factoring that we did in the polynomials unit. So 1, 2, 4, 5, 7, 8, and 10 are all going to be the examples I want you guys to do. So I'm going to work some of these ones over here on the right that are a little more challenging, but still give you the information you need to answer those other questions. So starting with number 3, greatest common factor. So anytime you're taking a greatest common factor, you're looking for not only the numbers to have a greatest common factor, but the variables as well. And remember, you can only take out the variable with the smallest exponent. So in number 3, both terms have an a, but the term on the right has a to the first power. And so I can only take out a to the first power, okay? You can't take out, you can only take out the variable with the smallest exponent. So I noticed really quickly that 5 would go into each of these, but then I thought, well, let me check and see. I know 30 doesn't go into 75, but what about 15? Because I know 15 is a factor of 30. And sure enough, 15 does go into both of those. Okay, so then now we'll check the variables. A to the second and a to the first, they both have an a, so I can take out the one with the smallest exponent, and you don't have to put the 1 there, okay? The first term has b to the third, the second has b squared. They both have a b, so I can take out the one with the smallest exponent. And only the first term has a c, so I can't take out a c. Now, to figure out what's left over in parentheses, I need to divide, I need to divide both my terms by the GCF. So 15a squared b to the third c divided by 15ab squared, and 30ab squared divided by 15ab squared. 75 divided by 15 is 5. A squared divided by a is a. B to the third divided by b squared is b. And we still have a c there. Minus 2, and ab squared cancels out. So 5abc minus 2 is what's left in the parentheses. All right, so that's a GCF. Number 6. 4, this is a difference of squares. And so, you know, when you're identifying these, the first question is it a difference? Yes. And the answer in this case, it is subtraction. And are both terms square rootable? Well, the square root of 4 is 2, and the square root of m squared is m. So that one's square rootable. And 81 is square rootable. The square root is 9. And n squared, the square root is n. So I can take the square root of both of those terms. And a difference of squares is written as 2 binomials. One's addition, one's subtraction. And the square root of the first term is what goes in the first position in both binomials. And the square root of the second term is what goes in the second position in both binomials. So that's going to be 9n. There we go. 2m plus 9n, 2m minus 9n. All right, trinomials. All right, so we need factors of c. So numbers that multiply to equal c that add to equal b. So I'm going to list the factors of 36, 36 and 1, 18 and 2, 12 and 3, 9 and 4, and 6 and 6. And so which will add up to equal 12? Well, there's only two that will add to equal 12, and that's 6 and 6. And so we're going to have two binomials. Okay. A plus 6, A plus 6. And if I were to multiply these two binomials out, and it's the same for all of these, if I were to multiply them out, I should get my original expression. All right, 11. I notice in 11 that the coefficient for the first term is bigger than 1, okay? So I'm doing slip and slide, okay? Slip and slide, or otherwise known as the AC method. Now, take A and multiply it by C. Okay, negative 2 times 12 is negative 24. Now I have C squared plus 5C minus 24. So I need factors of 24 that add up to equal 5. 24 and 1, 12 and 2, 8 and 3, 6 and 4. So 8 and 3 are the factors I need. So I can rewrite this as C plus 8, C minus 3, because 8 times negative 3 is negative 24, and 8 minus 3 is 5. And then I have to slide. So this was my slip, and this is my slide. And I'm going to divide by 12 now. Both of these fractions don't divide out evenly, but they can be reduced. This reduces to 2/3, and this reduces to 1/4. And then if you have a number left in the denominator, that slides just a little bit further in front of the variable. So I get 3C plus 2 times 4C minus 1. And that is my answer. And let's do it again here. Number 12, first step is to slip and multiply. 7 times 4 is 28. So I have V squared minus 16V plus 28. And I need factors of 28 that add to equal 16. 28 and 1, 14 and 2, 7 and 4. So 14 and 2 are what I need. So this is going to be V minus 14, V minus 2. They both needed to be negative because a negative and a negative multiply to equal a positive. And negative 14 plus negative 2 is negative 16. Now I need to slide that 4 back underneath. Okay, both fractions are going to reduce again. This will reduce to 7/2, and this will reduce to 1/2. And then I'm going to take that denominator and slide it just a little bit further. So I get 2V minus 7 times 2V minus 1. That is our answer. All right, moving on. Factor each polynomial completely. So now we've had some practice. You've seen the different types of factoring. Now we're going to be expected to put them all together and figure it out. So here we go. Number 13. Now, if we're talking about standard form, okay, and this is one of the clues to what type of factoring you're doing. Standard form of a trinomial, let me just erase the equals because these are all just expressions. Bx plus c. All right. So one clue that it's a difference of squares is there's no b. Okay, it's only a and c. So as we go through some of these, which ones don't have a and c? Well, which ones don't have b? This one doesn't have a b term, so I'm going to assume that's a difference of squares. 15 doesn't have a b term, so I'm going to assume that's a difference of squares. Let's see, what else? 17, 17's not as obvious. I do see a GCF, but I'm not sure if that's a difference of squares. So we're looking to see when there is a difference of squares. This one actually ends up being a difference of squares, and this one does too. But there's no B term, and it's harder to see in a couple of these because there's a GCF. But let's see, in a lot of these, this has got a GCF, this has got a GCF, and this has got a GCF. All right, so these are some of the more challenging polynomials to factor, but it's okay. So in number 13, I noticed really quick that these both have a 12. Well, 12 is my GCF, okay? If they both have a 12, then I can take a 12 out of the expression and then divide each term by 12 to see what's left over. So 12x squared divided by 12 is x squared, and 12 divided by 12 is 1. And what's left here inside the parentheses is the difference of squares, okay? So I can rewrite that as two binomials, and the square root of x squared is x, and the square root of 1 is 1. So 12 times x plus 1, x minus 1, and that is simplified. Number 14, I noticed really quickly that they each had an n, so n is going to be my GCF. If I factor out an n and I divide everything by n, I'm left with n squared minus 4n minus 60. And what I have left inside the parentheses here is a trinomial with a equals 1. So I need to see what factors of 60 will add up to equal 4. 60 and 1, 30 and 2, 15 and 4, and 10 and 6. Actually, 12 and 5 was one also. 10 and 6 are what I need, though, because that will give me 4. So I need n minus 10 because 4 is negative, and n plus 6. And that is my answer. So negative 10 times 6 will give me negative 60. And negative 10 plus 6 will give me negative 4. Okay, just so we're clear on how I'm getting these numbers. All right, 15. Is there a GCF? Well, the only thing I noticed was that it was subtraction. So since there wasn't a B term, I was just assuming it was difference of squares. But 8 and 21 only share a factor of 1. So no GCF. This is prime, meaning it cannot be factored. Okay, it can't be simplified in any way. There's no GCF. There's nothing I can do. Number 16, I noticed really quickly that each number, actually number 16 is one I'm going to let you do. But I noticed really quickly each number has ends with a 5 or a 0. So there's definitely a GCF, and then you should factor this, just like number 14. Number 17, so this is part of your homework, okay? 18 and 21 are all going to be part of your homework. 17, there is a GCF of 2, and each term also has a variable, so I can take out the one with the smallest exponent. That's going to be the first one, v to the first. And if I divide both terms by 2v, I'm left with 4 minus 49, whoops, getting ahead of myself, v squared. So that is what's left in the parentheses there, 4 minus 49v squared, is a difference of squares. So I have 2v times two binomials, one's addition, one's subtraction. The square root of 4 is 2, and the square root of 49v squared is 7v. And that's it. All right, number 19, we have a difference of squares and a GCF. In number 19, the GCF is 3. 27 and 75, both share a factor of 3, and both terms have an A and both terms have a B. So I can take out the ones with the smallest exponents, which is to the first power. And I need to see what's left over, so I need to divide both by 3AB. And when I do that, I get 9 minus 25b squared. And 9 minus 25b squared is a difference of squares. So I can rewrite this as 3ab times 2 binomials. One's addition, one's subtraction. The square root of 9 is 3, and the square root of 25b squared is 5b. All right, number 20. Looks like we have a GCF. 12, 16, and 16 all share a factor of 4. So 12y squared divided by 4 is 3y squared. Negative 16y divided by 4 is negative 4y. And negative 16 divided by 4 is negative 4. All right, so since a, the coefficient to the squared term, is greater than 1, I need to do the AC method, or the slip and slide method. So I'm going to slip and multiply. Okay, so I get y squared, and we still have the 4 out here, minus 4y minus 12. And we need factors of 12 that add to equal 4. 12 and 1, 6 and 2, 4 and 3. So 6 and 2 are what I need. And this is going to be y minus 6, since the 4 is negative, and y plus 2. And then I need to slide back under, so divide by 3. And I get, so 6 divided by 3 divides out evenly. That's y minus 2. But the 3 doesn't go into the 2, so I slide it a little bit further, and I get 3y plus 2. And that is the answer. Needed a little extra space for that one. 21 is GCF. And then just factoring, just like number 14. 18 is slip and slide. Okay. Trying to help you guys a little bit, even though I think you're capable of identifying the different techniques needed. All right, so, oops. Topic 2, dividing polynomials by a binomial using factoring. So on this page, in this topic, we need to factor the numerator and then see if any of the factors will cancel out with the denominator. So if I'm factoring the numerator here, I need factors of 20 that add up to equal negative 12, 20 and 1, 10 and 2, 5 and 4. So 10 and 2, this is going to be x minus 10, x minus 2, divided by x minus 10. And so the x minus 10s just cancel out. And what I'm left with is x minus 2. And that's my solution. 23, the numerator is, this is a slip and slide. So the last one I was able just to factor using the trinomial method, just, factors of c that add to equal b. Here I have to do some work. So I'm going to bring that numerator down here. 3y squared minus 16y plus 5. Slip and multiply. That's y squared minus 16y plus 15. Factors of 15, that's 15 and 1, 5 and 3. So 15 and 1 are what I need. This is going to be y minus 15, y minus 1. And then I need to slide, so divide by 3. And they divide out evenly on the first one, and I get y minus 5. And in the second, I have to slide that a little bit further. And I get 3y minus 1. All that divided by 3y minus 1. So the 3y minus 1s cancel out. And the solution is y minus 5. All right, 24. K squared minus 1 divided by k plus 1. So that looks like this. Well, I noticed really quick that numerator doesn't have a b term, doesn't just have a single x. So I'm thinking difference of squares, okay, DOS. And I can rewrite this as k plus 1 k minus 1, because the square root of k squared is k, square root of 1 is 1, divided by k plus 1. So the k plus 1 binomials cancel out, and what I'm left with is k minus 1. All right. Moving on, topic 3, standard form. Standard form is y equals, this is quadratics, okay? Also, what we've been dealing with in trinomials, but now we're looking at equations, okay? Y equals ax squared plus bx plus c. And when we're graphing quadratics in standard form, the first thing we do is calculate the axis of symmetry, which is also the x value of the vertex. Okay, so it helps us set up our tables. And the vertex form is y equals a times x minus h squared plus k, where h and k are the vertex and h is the axis of symmetry. So vertex form is really nice for graphing because it gives us the vertex and the axis of symmetry up front. But we can do it either way. Either way, it's not too hard. Number 25. Actually, before I go on, let me just say that all of this creates a U-shaped curve called a parabola. So you can see here, this is my vertex. This is my y-intercept. That's where it crosses the y-axis. And both of these points where it crosses the x-axis are called roots, okay, or zeros. There's a lot of names for them. Roots. Sometimes they're called solutions. And anytime you hear any of these, we're talking about where the graph crosses the x-axis. Okay. All right, so number 25, and we're also going to be using our calculators a little bit for these. Now you can do them by hand. It just takes a lot longer, okay? So for number 25, first thing I need to do is calculate, well, I need to define a and b. A is 1, b is -6, okay? That came straight from the equation. And now I can set up my axis of symmetry formula. So it's -b, so that's going to be -6 divided by 2 times 1. So that's 6 divided by 2, which is 3. So that is the value that goes in the center of my table. And then I choose 3 points to the left. So that's going to be 2, 1, and 0. And the 3 points directly to the right, which is 4, 5, and 6. So you're going to go to your calculator now, and you're going to put this entire equation, well, actually only this part, into your y equals, okay? And then you're going to hit second, and you're going to hit the graph button. And above the graph button, it says table, which is what we want to see. Okay, so we're looking for the table. And that is going to give us all our y values to help us fill out this table. Now you can do this by hand, just by substituting the x values into the equation and solving for y, but obviously that takes a lot longer. So the y values, it's because I've already done this, are 8, 3, 0, and -1. And they mirror over the vertex, okay? That's why it's called the axis of symmetry, because the graph is symmetrical on both sides of the axis of symmetry. So the y values mirror 0, 3, 8. All right, so we can start to put this on the graph. The vertex is at 3, so let's go ahead and label our axes. That's the y, that's the x. Start at the origin. I go right 3, down 1. Okay, there's my vertex. Okay. And I can graph the rest of the points. Right 2, 0. Right 4, 0. Right 1, up 3. Right 5, up 3. And 0, up 8. There's 10 blocks in each section, so I knew really quickly how to get to 8. And then 6, 8. Okay, connect the dots. Not that straight, but I'll take it. Okay, So the domain, the x values for this graph going left and right, it looks like this graph continues to go in both directions, and it's not very steep, but it is continuing to go in both directions, so the domain is going to be all real numbers. In fact, it's going to be all real numbers for every one of these graphs, just giving you the heads up. All right, now, the y values are a little different. So this graph doesn't really start to have y values until you get to y equals -1. So the axis of symmetry, the range is everything greater than -1. Okay, this graph has values for everything greater than or equal to -1 on the y-axis. The axis of symmetry, we already defined that. Okay, that is this vertical line here that's splitting the graph into two equal parts. So that is at x equals 3. The vertex right here, that's the point in the middle of the table, so 3, -1. The places where this graph crosses the x-axis, here and here, are 2 and 4, and I always like to list them from least to greatest. And the y-intercept, the place where the graph crosses the y-axis, is up here at 0, 8. All right, so number 26 is going to be yours for homework. Okay, it's very similar, opens down. Let's keep going. 27. All right, 27 is still in standard form. 28 and 29, we get to dabble in vertex form a little bit. So in 27, I'm going to calculate the axis of symmetry. Let's see, A is 3, B is 0. That's going to make my axis of symmetry easy to calculate. -0 divided by 2 times 3, that's 0 divided by 6, which is 0. All right, 3 values immediately to the left are -1, -2, -3. 3 values to the right are 1, 2, and 3. All right, so I'm going to put this equation into my y equals. I'm going to go second table, and I'm going to find the y values for these x values. And since I've already done that, it is 24, 9, 0, and -3. And then they reflect over the vertex. So 0, 9, 24. All right, so this value in the center, we already said that's our vertex. So let's go ahead and plot it. 0, let's label our axes. That's the y, that's the x. Down 3, so right there. Okay, so then I'm going to go to the left side, -1, 0. Then the right side, 1, 0. -2, 9, that's way up there. This is a really steep graph. It's been stretched out. And then 2, 9, so that's going to be right there. I'll connect the dots. Okay, so let's start to drill into some of these things. The domain, like I said before, is all real numbers. The range, it looks like we don't start to have range values until we get there, where y is greater than or equal to -3. The axis of symmetry, that is the vertical line that splits the graph in two, and it actually happens to be the y-axis in this problem. Okay, so that is x equals 0. The vertex is this point right here in the center of our table, also the turning point. That's what we call it. You know, as you go from left to right, you're going down and then up. The vertex is the turning point of the graph. So that's at 0, -3. The x-intercepts are here and here. That is at -1 and 1. And the y-intercept, well, it just happens to be the vertex here. The y-intercept is at I'm sorry, 0, -3. Okay. All right, like I said before, 28 is for you. This is vertex form, and in order to be able to graph it, you might need to watch me do number 29. So in number 29, we have another quadratic in vertex form. In this one, there's no b, so when there's no b, b is 0. I'm sorry, there's no k. When there's no k, k is 0. And when you're taking values out of vertex form, and I'm actually going to do it for both of these, the value that it goes in for x, when you take it out, is always the opposite sign. Okay, so vertex form is y equals a times x minus h squared plus k. So if you have a 1 that was substituted into this formula, it's going to become negative because the formula is negative. Okay, just like if I had a +1 here, I would need to take out a -1 because a negative and a negative are how that became positive. So just to be clear, the x value, or the x value that you take out of this formula, is always the opposite sign. So this is going to be +1. And since there's nothing, there's no k, k is 0. So my vertex is at 1, 0. And let's go up here to 28 real quick just to get the vertex. It's always, the x is always the opposite, so it's not +4, it's -4. And then 9 is the y value of the vertex. All right, so that kind of helped you get started on number 28. All right, so let's finish up number 29. 3 values to the left are going to be 0, -1, and -2. 3 values to the right are 2, 3, and 4. Now, you're going to put this equation, just like it's written there, 2 times parentheses x minus 1 raised to the second power, into your calculator, into your y equals, then go look at the table. When you do that, you should get the y values that are corresponding with these x values, and those are 18, 8, and 2, and they reflect, so it's 2, 8, and 18. Now I can go ahead and put this on the graph. It's going to be 1, 0, 0, 2, 2, 2, -1, 8, and that's all I'm going to be able to get on here, 3, 8. Okay. So there's my graph. My domain is all real numbers. My range, well, I have range values everywhere from y equals 0 and up. So my range is y is greater than or equal to 0. My axis of symmetry is right here at x equals 1. So that's x equals 1. My vertex is at 1, 0. My my x-intercepts, well, I only have 1 here. It's at 1. Those are my attempts at brackets. And the y-intercept is right there. Actually, I'm going to use green for that. That's at 0, 2. Okay. All right. Next topic, transformations of the quadratic function. So recall that the vertex form describes transformations from the quadratic parent function, y equals x squared. So this is like the most basic quadratic function there is. It opens up. Okay, it looks something like this. Okay, and the vertex is right at the origin. So given y equals a times x minus h squared plus k, all of these things are things that change the way this graph looks. Okay, so if you're adding h, then it shifts left. If you're subtracting h, it shifts right. That one's a little tricky because it's always opposite of what you think for the x's. And it goes back to the fact that the formula has a subtraction sign. So what goes into it is always opposite of what appears. And then the k, if it's being added, it shifts the whole graph up. If it's being subtracted, it shifts the whole graph down. And the A in front of the parentheses, if the absolute value is greater than 1, it creates a stretch. And that's why we saw this graph up here. See, A is 3. You saw how skinny that graph was. And even in 29, A was 2. So you see that's a little skinnier than some of the other ones we did. And then if it's less than 1, it's a compression. So I don't see any that are compressions, but a compression, instead of it just looking like a regular quadratic, okay, it gets short and fat like that, okay? So that's when A is less than 1, but greater than 0. All right, so that's pretty much everything, except if A is negative, then the graph reflects. So instead of it opening up, it opens down, okay? All right, so here we go. Given each equation, describe the transformations from the parent function y equals x squared. All right, so in number 30, 5 is being added to x, so that's going to be a shift left 5. It's always the opposite. If it's plus, it goes to the left. If it's minus, it goes to the right. And then it's going to be a shift up of 3. And that's it. There's no A. Nothing in front of the parentheses. All right, 31. Well, let's start out with the shift right 4. And then we have -2 being multiplied, so that's our A. This means it's reflected, because it's negative, reflected over the x-axis. And stretched by a factor of 2. All right, number 32. I will let you guys have this one. Just be careful. There is a compression in this one. So that's part of your homework. And I'm going to leave you with 33. I'll do 34 and 35. So transformations from the function y equal x squared are described below. Write an equation to represent the new function. So we're writing them in the form y equals a times x minus h squared plus k. We're writing them in vertex form. So number 34 says it's a vertical stretch by a factor of 4. So y equals 4. Then translated 5 units down. So 4x squared minus 5. Okay, I didn't need parentheses because there was no shift left or right. All right, and then number 35, reflected over the x-axis, so I know A is negative. Then translated 7 units left, so that's x plus 7 squared, and 1 unit up, plus 1. All right. Topic 5, solving quadratic equations. The solutions to a quadratic equation are the points at which the parabola intersects the x-axis. Solutions are also referred to as roots, zeros, or x-intercepts, and we referenced that earlier on in this video. Quadratic equation can have 2 solutions, one solution or no real solutions, and this is just based on where the quadratic lands. So for example, if we have a quadratic whose vertex is on the x-axis, then we're only going to have one root. If we have a quadratic whose vertex is below the x-axis, then it can intersect in 2 places. Okay, so here we have 1. Here we have 2. And then there's also a scenario where, maybe our quadratic is just floating around in space somewhere, like out here, and it never crosses the x-axis. That's also possible. So we're going to use our different methods that are listed over here. We have factoring. Remember, this includes difference of squares, just regular factoring, and slip and slide. Okay. Square rooting method, we're not completing the square, so we're going to, if factoring doesn't work and square rooting doesn't work, we're going to use the quadratic formula. Okay. All right, so number 36. I forgot to mention in factoring also we have just taking a GCF, and that's one way we can solve sometimes. All right, so number 36, this is a GCF, and I'm going to try to label these as I go so you guys can get some point of reference with them. All right, so number 36, this is a GCF. 37 is a GCF. 37 you will do for homework, and 38 you will also do for homework. This is a GCF and then a difference of squares. All right, so number 36, x squared plus 8x equals 0. Now, one thing I want to mention before we get into some of these is if it's not equal to 0, then you have to get it equal to 0. So like for number 37, I need to subtract, I need to subtract 10x from both sides so that I can move the 10x to the left side of the equation so I can factor it. So it has to be equal to 0 before you can do anything, okay? The only exception is square roots. Square roots, you solve for the x squared term. But 9 times out of 10, we're going to be getting it equal to 0. So now we can get started. X squared plus 8x, both have an x, so I know I can take out the one with the smallest exponent. If I divide both by x, I get x plus 8 left over in the parentheses. And now I can set each one of these equal to 0. So x equals 0, x plus 8 equals 0, and then just subtract 8 from both sides to solve for x. So in number 36, my two zeros are x equals -8, and this should be one of my fancy brackets, and 0. And I always try to write them in least to greatest order. Number 37, subtracted 10x from both sides, and now it looks like 4 and 10 have a GCF of 2, and since they both have an x, I can take out the one with the smallest exponent, divide both terms by 2x to see what's left over, and I get 2x minus 5. So now I can set each one equal to 0. 2x equals 0, divide by 2, and x equals 0. Anytime you have a variable that's factored out as a GCF, one of your zeros is going to be 0. 2x minus 5 equals 0. Add 5 to both sides. Divide by 2, and x equals 5/2. So x equals 0 and 5/2. All right, 39. Got to get it equal to 0, so I'm going to subtract 6 from both sides. And I get 4x squared minus 49 equals 0. Ding, ding, ding. This is a difference of squares because I have no b term, okay, no just regular x term, and both of these terms are square rootable. So I'm going to have two binomials. Take the square root of the first term, that's 2x. The square root of the second term is 7. Now I set each one equal to 0. Solve for x, subtract 7, divide by 2, add 7, divide by 2. So x equals -7/2 and 7/2. All right, 40 and 41, these are both square roots. So square root problems also do not have a b, so they're similar to differences of squares in that sense. But it's pretty clear because their factors, or their coefficients are not perfect squares. So number 40, I'm going to add 30 to both sides. So this is the one time where we're not trying to get 0 on one side of the equation. Okay. And then to get rid of 1/2, because I'm trying to isolate my x squared, I'm going to multiply by 2 on both sides. Multiply by the reciprocal to clear a fraction. And so x squared equals 80. And then I can take the square root of both sides. So x equals plus or minus the square root of 80. And I happen to know that the square root of 80 is an irrational solution, but it can be simplified, okay? So we need the largest perfect square factor that goes into 80, and that happens to be 16. 16 times 5 equals 80. So this and this are equivalent. Now I can take the square root of 16, and that's 4. So I'm left with 4 times the square root of 5. So x equals 4. X equals plus or minus 4 times the square root of 5. All right, 41. Subtract 9 from both sides. So we're going to try to isolate the x squared term. 17 minus 9 is 8. Divide by -1. And x squared equals -8. And I'm going to pump the brakes, because you cannot take the square root of a negative number. There's nothing that you can multiply by itself to equal a negative. So this, no solutions. All right, moving. Next page, same thing. All right, so number 42 and 45 are going to be part of your homework. And 48 and 49 we're not going to do. They're just extra. No, they're not. There's nothing different about them. 42 is just regular factoring. You do have to get it equal to 0 first, so subtract 6. 43 is factoring as well, and I'm going to do that one. Actually, changing my mind. I want you guys to do 43 as well. Subtract 18x, add 81. Get everything on the left side of the equation before you start to factor. Don't move x squared because we want to keep it positive, okay? All right, 44. This is going to be the quadratic formula. Okay. Okay, quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So there's the formula. Hope you like my song. First thing to do is define a, b, and c. A is 1, b is -4, and c is -14. All right, so x equals -4, which is going to turn into +4, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And the best thing to do when you're simplifying, because these can be just really overwhelming for people. When you're simplifying the quadratic formula, always simplify the discriminant first. The discriminant tells us how many solutions that it will have, and if it's greater than 0, it has 2. If it's equal to 0, it has 1. If it's less than 0, it has none. So we'll do that part first, and you can do that in your calculator. Only thing I will suggest is that you put this -4 in parentheses before you square it. So I can type that in just as it's written, parentheses -4 squared minus 4 parentheses 1 parentheses -14. Okay, so I literally typed it in to my calculator just the way it's written there. And I get 72. Okay, so I have x equals 4 plus or minus the square root of 72 divided by 2. And that looks a lot more manageable now. All right. Now, I happen to know that the square root of 72, it's not a perfect square, unfortunately, but it can be simplified. This is an irrational number. Can be simplified to the square root of 36 times the square root of 2, because 36 is the largest perfect square factor of 72. And the square root of 36 is 6 times the square root of 2. So I can simplify this to x equals 4 plus or minus 6 times the square root of 2 all over 2. And then we can divide 2 into 4 and to 6, okay, and simplify just a little bit more. 4 divided by 2 is 2, plus or minus 6 divided by 2, which is 3 times the square root of 2. And that is your answer. All right, 45 is also the quadratic formula, and you will have to simplify an irrational solution. Over here, it's going to be the square root of 48, which can be simplified into the square root of 16 times the square root of 3, or 4 times the square root of 3. So you can use that. You're welcome. Number 46, this is a GCF and just regular factoring. So first thing I need to do is get everything on one side. Again, leave the x squared term alone so you don't make it negative, okay? So I'm going to subtract 30 and add 9x to both sides. I'm just going to do it all at once, okay? Cancels out on the right side, and I have 3x squared plus 9x. I'm going to write it in standard form from least to greatest exponent. All right, so now I can tell that each of these coefficients and the constant have a GCF of 3. So if I take out a 3, what's left over? Well, I have x squared plus 3x minus 10 equals 0. And then what's left in parentheses here can be factored. So I need factors of 10 add to equal 3, 10 and 1, 5 and 2. 5 and 2 will work. So this is going to be x plus 5, x minus 2 equals 0. And at this point, I really don't need my GCF anymore, okay? Other than just having it there to represent how to get back to that original function. I'm only asking for the 0, so we can just set each of our binomials equal to 0 and solve for x. So we're going to subtract 5, x equals negative 5, add to x equals 2. So my solutions, negative 5, comma 2. All right, 47. So really quickly, I realized that this trinomial, this quadratic in standard form, has an a greater than 1. So I'm going to be using slip and slide. Okay. So I'm going to slip and multiply, and I get x squared minus x minus 12 equals 0. Now I need factors of 12 that add to equal negative 1, 12 and 1, 6 and 2, 4 and 3. And that's going to be the factors I use. So this is going to be x minus 4 because the b term is negative, so I need the larger factor to be negative. And x plus 3 equals 0. Now I can't forget my slide. Divide by 6. And both of these fractions I need to simplify. This one will simplify to 2/3, and this will simplify to 1/2. And then I have to slide that remaining denominator in front of the variable. So I get 3x minus 2 times 2x plus 1 equals 0. And almost done. Set each binomial factor equal to 0 and solve for x. Add 2, divide by 3, x equals 2/3, subtract 1, divide by 2, x equals negative 1/2. So my two roots, my two zeros are least to greatest, negative 1/2, and 2/3. All right, so that's it for that page. Let's keep going. This was finding the zeros of quadratics. Topic 6, application problems. All right, so for number 50, the dimensions of a rectangle can be represented by the expression. So we have a rectangle, and I always like to make pictures. X plus 7 and x minus 3. And I know the area is equal to 75. So area of a rectangle is equal to length times width. So I can say 75 equals x plus 7 times x minus 3. And it's asking to find the value of x. All right, so we're going to have to do some work here. First thing we need to do is multiply our two binomials. So x times x, that's x squared. X times -3, -3x. 7 times x is 7x, and 7 times -3 is -21. Now I can combine like terms, so we get x squared plus 4x minus 21 equals 75. And now I need to bring this 75 over so that I have my equation set equal to 0 and I can factor it. Okay, so we need to subtract 75 from both sides. And I get x squared plus 4x minus 96 equals 0. Okay, so all I have to do is factor this now, and I will have what x equals. So I need factors of 96. Let's see. There's a bunch. 96 and 1. 48 and 2. 32 and 3. 24 and 4. 16 and 5. And 12 and 8. Now, if you don't, let me rephrase this. If you're not great at finding factors, and sometimes with numbers like this, it's not easy, okay? So you can use your calculator. If you press y equals, and then in this case, we were trying to find the factors of 96. So in the very first place where you can put an equation, put 96 divided by x. Okay, then go to your table. So you're going to hit second, and you're going to hit graph because table is above graph. And you can see in your table all the factors, and it's really great because sometimes you'll find some that you didn't think about, this was the case for me on this problem. So 12 and 8 are what I need because they'll add up to equal 4. So I have x plus 12, x minus 8 equals 0. And then I set each one equal to 0. X plus 12 equals 0. X minus 8 equals 0. Subtract 12. X equals -12. Well, we can't have a negative length, right? So that one's not going to work. And then we have add 8 to both sides, and x equals 8. So the side length, the value of x is 8. And then we could use that to determine, see, 8 plus 7 is 15. 8 minus 3 is 5. So there was the length and the width, even though that wasn't asked. All right, so number 52, I'm going to leave for you guys. A toy rocket is launched from a platform that is 48 feet high. The rocket's height above the ground is modeled by the equation. What is the rocket's height at 2 seconds? So this is asking when x equals to what is y. Okay, so plug it in, find it out. That's going to be the height after 2 seconds. Number 51, the stress distribution on a structure is given by S equals 2x squared plus 4x minus 30, where S is the stress in pounds per square inch and x is the distance in feet from a reference point. At what distance is the stress equal to 0? So it's asking for the zeros of the quadratic, okay? So S equals, this. In fact, I'm going to swap that S out for a 0. 2x squared plus 4x minus 30. And I can tell because these are all even numbers that they have a GCF of 2. And if I factor out a 2, then I have x squared plus 2x minus 15. And I can factor that. X squared plus 2x minus 15 equals 0. Factors of 15, 15 and 1, 5 and 3. And 5 and 3 will give me 2, so I have x plus 5, x minus 3 equals 0. And if I set each one equal to 0, x plus 5 equals 0, x minus 3 equals 0. Subtract 5, x equals negative 5. Well, I'm pretty sure we don't have a negative distance here. And x equals positive 3. So x equals 3 is the, let's see, distance in feet from the reference point. And that is your answer. All right, 53 and 54, these are both quadratic regression problems. So just like when we're doing linear regression or one variable statistics, you're going to choose the stat button. And then the very first choice, you're going to choose edit, and you're going to get your columns. Your L1 is going to be the X values. Your L2 is going to be the Y values, okay? And then once you've put in all your X and Y values, you're going to hit stat again. And then you're going to go over to the right one and calculate. And I believe it's number 5. I'm going to make this a little bigger. Quadratic regression. Okay. I knew to choose quadratic regression because it asked me for the curve of best fit. All right. So anytime you're dealing with years, always change the first year to 0 and every year following. So that would be like 1, 2, 3, 4, because these are 2008 is 1 year from 2007, 2009 is 2 years. And let's say, for example, they gave us 2018. Well, that's 2018 minus 2007, which is 11, okay? Because that's what they're asking for here. All right, so I put that into my calculator just as it's written, and I get the equation, and I rounded to the nearest tenth. Y equals 5.9 x squared, minus 8.8x plus 33.3. And if that's my equation and I need to predict the college's budget in 2018, then I can substitute 11 in for x and solve for y. And when I did that, I got 650.4 million. So this is growing pretty fast. All right, so number 54 is going to be for you. I hope this wasn't too painful. We're splitting it up over 3 days to help ease any frustrations that you might find in going back through some of this material. But stick with it, guys. We're almost there. For those of you who have been working hard all semester, all year, thank you so much. You are amazing. I'm your teacher. This is the way.